Welcome to a lesson with Dr. Powell. Let's take a look at adding fractions. All right, so let's suppose we have 2/3 plus a fifth. Now, how do we add these things? If we think about what is this talking about? This is saying we have two of something. We have 2/3, and this is saying we have 1/5. So we have two of something, and one of something, but these things are different. But we like to be talking about the same thing, so we could think about how to add them. All right, so we have to think equivalently. 1/3, 1/5, how could we relate them to something that's the same? Well, we think about fractions, common ratios, and things. We could think about multiplying top and bottom of this by the same thing. Or you could think, okay, a third is like the same thing as, think about 15ths. Why am I thinking about 15ths? Well, 3 times 5 is 15. If you take a third of a fifth, you will get a 15th, right? And if you take a fifth of a third, you'll get a 15th as well. Yeah, what we can do is we could just multiply top and bottom of this by 5, top and bottom of this guy by 3. Now what are we talking about? We're talking about 15ths now. That's common. So we have 1/3 is the same thing as 5/15ths. You can see you're getting the same ratio here as a third because you multiply top and bottom by the same thing. So 5/15ths. So you're going to have two of those. And then we're adding to, what do we have? 1 times, and it's a fifth, but we're going to be thinking of it as 3/15ths. 3/15ths is the same thing as a fifth. So we've related thirds and fifths to 15ths. All right, now let's think about this. 5 groups of 15ths, right? Same thing as 2 times 5, so 10/15ths. So this is 10/15ths. And what is this over here? This is going to be 3/15ths. All right, so we have 10/15ths and 3/15ths. How do you add that together? Well, it's going to be 13/15ths, right? Because you have 10 of something, 3 of something, add them together, it's going to be 13 of them. So 13/15ths. Now, algebraically, you could think, well, really what we're doing is we found something that was common. We found a common factor between these two terms. So a term is, in an expression, something separated by pluses or minuses or something like that. So you have a term and a term. If you can find something common in this term times something else, something common in this term times something else, and this is the common thing, then what you could do is you could just factor out the common thing out of the sum. And we have those two things added together. So this thing and that thing added together in here. Okay, and maybe I'll notate it differently somehow so you can think of them as being different things. But anyways, essentially that's what we're doing. See the 1/15th, so we're talking about the same thing. We could have just factored out that 1/15, and then we're left with 10 plus 3. And that's really all we're doing. So we're finding a common denominator. Probably heard that many times before, but that's essentially what finding a common denominator is. It's finding something common that we can factor out and then add what's left. What's left is always numerator ideas, so you're just adding in the numerator. But this is a kind of a nice intuitive way of thinking about what's happening. So let's apply this basic idea to the following. What if we had x over 2x plus 1, and then we have plus 1 minus x squared all over x plus 1 times x. All right, let's kind of try to think about what's common, kind of a least common multiple. So a multiple that's least among multiples of each of these guys right here, because we want to be talking about the same thing, right? Just like we want to talk about the same thing here. We're not talking about 15ths. Here we're talking about different things because we have different denominators. All right. Well, you see x plus 1 will be a factor. X will be a factor. 2 will be a factor. Just kind of think of that idea together. We're going to be having, in the end, a common factor of, and I put it in the denominator thing just like I had 15 thinking of 15. Well, here, in place of that, I'm going to think of 2x plus 1, x. These will be the common things we're talking about. All right. And I want to know, essentially, like, okay, I was thinking I had 1 minus x squareds of these, but how does that, but how many will I have of these guys? I'm taking 1/2 of all of those guys. I mean, let's see. Let's think about this. So this is saying 1 minus x squared times 1 over x plus 1x, right? All right, but we want to be taking 1/2 of those, which means we're going to be talking about double of them. Hey, you know what? That's the same thing as like multiplying top and bottom of this fraction by 2. Right. Multiply top and bottom by 2. See, everything's really, in the end, equivalent to multiplying top and bottom by the same number, or dividing top and bottom by the same number. At least a lot of different things with fractions are. So we have 2 over 2, multiply that through, and notice that we have the right denominator, and then in the numerator, 1 minus x squared times 2. That's how many of these guys come from this term right here. So we have 2 times 1 minus x squared, and that's what we're going to have from this part right here. So 2 1 minus x squared, because that's the numerator right here. The denominator I just put off to the side over here. Okay, so what part's coming from over here? So what's lacking? What do we have to multiply top and bottom by so we get that denominator? Looks like we're going to have to multiply top and bottom by x. Okay, now we have the right denominator. It's like we got the right denominator over here. In the numerator, we're going to have x times x. So that's the part right here that we're going to have come from this term right here. And so when we factor out that common denominator right there, we're left with this addition in the numerator. So x squared plus that, we could work that out. Distribute the 2. I mean, we could further rewrite this because I see that there's going to be something common here that'll cancel. So sometimes if you see like something might cancel when you multiply it out, go ahead and do it if it looks like it's going to make it look a little simpler. 2 minus 2x squared, and then we have x squared on the top, all right? So x squared minus 2x squared, that's going to be a negative x squared. So we got 2 minus x squared on the top. That's the numerator. I'm going to slide the denominator back in. I just simply did that just so we could kind of think algebraically what's happening. It's really factoring out something that's common. Divided by 2x plus 1 times x. And that right there is the result, or I mean, we added 2 fractions, but it's simply, you know, it's kind of silly because we say add 2 fractions and what do you get? But really what we're saying is rewrite this addition of 2 fractions as 1 fraction, like just rewrite it in another form. By virtue of just writing down the addition of 2 fractions, you've really added the fractions. You've come up with an expression that represents what you want. We're just rewriting that expression in another form, one that doesn't have a plus in the middle with 2 fractions. But essentially it's the same thing. So we're just rewriting. Again, this is what you'd call simplifying an expression. We start with an expression and we simplify it to get something. We're not solving anything. Do not use the word solve here. We are simplifying. We have an expression that we started with and we rewrote it in a simpler form, perhaps simpler depending on what our purpose or our goal is. Thanks for watching.